Good morning, everyone. Welcome to today's Canada C3 Hangout. My name is Joe Grabowski. I'll be your host for today, and I'm very excited to join back aboard the expedition vessel today. So a little background for those who don't know, Canada C3 is a signature project for Canada's 150th anniversary, and the centerpiece is a 150-day sailing journey from Toronto to Victoria via the Northwest Passage that's going to connect Canadians from coast to coast to coast and inspire a deeper understanding of our land, peoples, past, present, and future. The expedition is divided into 15 legs and has a cross-section of Canadians joining at different times, from scientists to artists, Indigenous elders, historians, community leaders, youth journalists, and educators. So today we're in leg 13 off the coast of British Columbia, being joined by Brian Hunt and Jade Shiller. Brian's an oceanographer who was born in South Africa, studied in Australia, then settled in Canada. He researches the critical role of plankton in marine ecosystems and how that role is changing with the shifting climate. And his research has taken him all over, from Antarctic oceans to the Arctic, from Mediterranean to the tropics. Jade's a research scientist and a biological oceanographer from the University of British Columbia in Vancouver, British Columbia. Her research focuses on low oxygen regions in the oceans and the microbial communities that live there. And as our climate is continuing to change and those zones expand, it's even more important to understand what's going on. So Brian and Jade, thanks so much for joining us today.
Yeah,
thanks for having us.
So you are on the deck of the C3 right now, and you're in one of the laboratories, one of the, almost like a cargo container that's been converted to a laboratory.
Yeah, that's right. This is our, we call it our clean lab. So it's a facility we like to keep dry and clean so we can do our processing of particularly the environmental DNA samples and make sure we don't have any contamination. We can also have all our computers in here, and they're safe from the moisture. We can do all our data entry and that type of thing. We have another lab at the front of the ship where we do all the dirty work, working with the messy water samples, the plankton, the sediments, and that type of thing.
All right. Well, before we go further, let's meet some of the groups joining us. We have Mr. Candela's group. They're grade 7s, and they're joining us from Kingston. How's everybody doing this morning?
Good.
All right. And then it looks like we've got a group joining us from the Canadian Museum of Nature in Ottawa. How's everyone doing over there? All right. Very cool. And I can see our viewership starting to climb on YouTube. So anybody who is watching live on YouTube, can you use the chat sidebar? Let us know if you're a classroom, where you're watching from, and then we'll get some of your questions a little bit later. But for now, why don't you guys tell us a little bit about what you're up to on the C3 and how it's been so far?
Okay.
All right. So, well, so what we're doing is we have a whole bunch of science projects. Right now, and this is leg 13, we're busy managing 10 of those. And one of the main projects is where we're measuring environmental DNA. So it's the molecular material that's DNA that's shed by all the animals that are in the water. We collect water samples and we capture that DNA. We filter it onto little filters and we freeze it. We take it back to the lab in Vancouver, and then we can measure the DNA that was in the water, and it tells us which species of animals have been in that area. So we're doing this on a transect right around Canada, and then we can look at the diversity of life across the Canadian coasts. So that's one of our main projects. And then there's a few other things. We're taking plankton samples right around the coastal regions so we can look again at the diversity of plankton. And we're measuring microplastics, small plastic particles that are distributed in the ocean. It's one of the pollutions that humans are producing, and we're measuring the amount of microplastics in the nearshore environments around Canada. And then we're doing some regular sort of observations on the vessel, looking at the bird life, mapping out the species that we see, also marine mammals. We have an entomologist on board. He's going out, getting onto land every day and collecting flies in particular, but collecting insect specimens to look at the diversity again of insects in the coastal regions of Canada. So those are some of the projects that we're doing on board. And that keeps us busy every day. We go out every day on the water, we get onto the land, we collect all our samples, and at the same time, we also in this incredible location, and we're trying to make the most of the other aspects of the voyage, meeting with the local communities and learning about their lives and how they're interacting with their environments in these coastal areas.
Yeah, it's been a really great to do my job in probably the prettiest place in the world. Yesterday I got to go kayaking, but I was also collecting samples from my kayak, so got to do some pretty cool work.
And yeah, yesterday out on the water, it was a beautiful sunny day. Today is kind of misty and it's starting to rain, but we're out on the water. We saw 4 or 5 humpback whales, hundreds of seabirds. It's just a beautiful wilderness, this in Haida Gwaii. It's just amazing.
Amazing. It sounds absolutely beautiful. It's definitely a part of the country that, well, it's just an amazing experience to do this from the ship and see places probably a lot of people don't get to.
That's right.
All right, excellent. So I know an area that you both look at are small things in the ocean, like microbes and phytoplankton. So maybe we can set the context a little. Why are they so important? Why should we care so much about things so small in our ocean?
Yeah, well, we could take a selfish view of it, and we could say that we like to eat things that come out of the ocean. And the big things that we like to eat, like salmon, they need those little things. Phytoplankton take energy from the sun, just like plants on land do, and they convert that into their biomass, their bodies. Crabs that's swimming through the ocean, and those get eaten by the salmon, or by small fish that then get eaten by the salmon. So they're really important. And the microbes help take the waste that all of those animals and plants produce and break it down so it can be used again.
So you can think about it like, think about it in the context of a land system. So you have the phytoplankton are the plant life, basically. They're all the plants that the grazing animals, like on land you might have, it could be rabbits, it could be deer, these types of animals. In this case, it's tiny zooplankton. The tiny zooplankton are eating those tiny plants. And then, as Jade was saying, this gets progressively passed up the food chain through small fish like herring. We have lots of herring in this area. They're eating the zooplankton, particularly the copepods and the krill. And then, we've seen the seagulls eating the herring. Big flock of seagulls just outside here, eating the herring this morning. And so this is how it works. The plants, those tiny microscopic plants, the phytoplankton, making life in the ocean, and this is feeding the rest of the food web.
So even if you're not a seafood eater, every other breath that you take, the oxygen in that breath was made by the phytoplankton. So we need them to breathe. We need them as a food source for a lot of people. For a lot of communities, it's really culturally important, which might be hard for people in the middle of the country to connect with. But yeah, the little guys in the ocean are really doing all the work that's making it possible for us to live and all the ecosystems around us to function.
All right, and boys and girls, if you listen really carefully, every once in a while you can hear the foghorn going off on the ship because it sounds like you're having a bit of a foggy morning.
Yes.
That's right. Expecting a rainy next couple of days.
Yeah. All right.
Yeah.
So excellent point about the importance of microbes and phytoplankton and the role that they do play in the ocean. So I know one area you're looking at is climate change. So what are you looking at there? What kind of impacts are you looking for, or have you found maybe?
One of the main things we're looking at is the effects of changing ocean temperature. And so we've seen over the last few years, in particular, really dramatic changes in ocean temperature. In 2014 and 15, we had a marine heat wave on this coast. And this causes dramatic changes in the animals that you'll find in a given system, because some animals do well in warm water and some don't. And so we typically have cooler conditions on this coast, and when we have really warm conditions, we change the system. And different animals are successful, and then the resident, the fish species, the herring and the salmon that are dependent on these cold water plankton, they don't do so well when you have the warm water plankton, and there's a few reasons for that. The warm water plankton tend to be smaller, harder to eat. You have to eat more of them to get the energy that you need, and also these warmer plankton, they don't have as much fatty insulation. So the cold water plankton accumulate fats. We just refer to them as lipids, and they do this as an energy store to keep them through the winter, lasting through the winter period. The same way we'll provision ourselves for the winter, and these fat stores are very energy full and very, very rich, and so they're a very good food source. And when we shift the community from a cold to a warm type community, the plankton community, then we lose a lot of those lipid stores, and that affects the health of the fish that usually eat those cold water plankton.
It would be like, instead of having a nice hearty bowl of oatmeal for breakfast every morning, you switch to having a bag of chips. It just isn't going to give you the nutrition to get you through the day.
So that's one of the things we're looking at, is this the effects of warming, and so this is really interesting. If you're thinking about this transect, this coast to coast transect that we've done around Canada, we're looking at the distribution of animals, and you think about it, at the top we have all those cold animals in the Arctic, and then going east and west and going south, we get down into warmer waters. And if we look at the animals distributed along that transect, you go from warm type animals in the south and going to Arctic animals in the north. And by mapping those out, by looking at the change in the distribution of those animals, we can see the change over time as warming happens. And that's what we're expecting to see as the ocean gets warmer and warmer, as these animals in the south start to move northwards towards the Arctic.
The other thing that's happening as the oceans warm is the chemistry actually tends to change. So if you think of a nice can of pop that you've just taken out of the fridge and you open it up, it'll probably stay fizzy for a while. But if you take a can of pop out of a warm room or out of the pantry and you open it up, it'll get flat really fast. So cold liquids like your cold pop can hold dissolved gases a lot longer. So the warm ocean is actually losing a lot of its oxygen. And most life needs oxygen. So there are these areas in the ocean that are very, very low in oxygen or have no oxygen at all. And some people are referring to these as dead zones because fish can't live in them. So these dead zones are expanding, which has huge impacts on fisheries and the whole food chain and the ecosystem as well.
All right, those are some excellent points. I think we hear so much. Oh, sorry, go ahead.
But I don't know if you can tell, but the ship has started rocking quite a bit. So if the view looks like it's tilting a little, that's because it's tilting a little.
Would you be able to? Maybe we can try and give you a view outside. I'm going to pass the camera to Felicity.
Sure.
Hey, everybody. So I'm just going to take you outside and try not to fall over because the ship is moving a lot right now. So this is the weather today. And I don't know if you can see, but there's a lot of waves out there in the ocean.
All right, hopefully that wasn't too dizzying for you guys. I'm just gonna take a couple steps back up into the lab here. Get us set back down on the bench top. All right.
All right, well, thanks for giving us a little peek at what you're seeing. It's always nice to see a little bit of the context, and incredibly jealous, landlocked here in Guelph, Ontario. It's a little ways from the closest ocean.
Yeah.
All right. Well, before we meet some classrooms, I want to give a shout out to Mr. McPhee's. He's actually got some grade 4s and 5s with him at Fernwood Elementary School in Salt Spring Island, British Columbia. So they're watching along on YouTube. So don't forget to send us in your questions. And any other classrooms who are watching along, use the chat sidebar, let us know and send us some questions. So let's meet some of our classrooms and take some questions. So let's start a little different today. Let's visit the Canadian Museum of Nature first in Ottawa, and let's see if there's any questions over there for us.
Yes, hi. We have a question here about the dead zones. The question is, are the seasonal dead zones turning into permanent dead zones? And when you said they're expanding, are they also becoming more numerous?
Wow, that's a really great question. I think the answer to both of those is yes. There are some places in the ocean where it's natural for there to be a seasonal dead zone, and maybe it lasts 2 months or 3 months, and now it's lasting 3 or 4 or 5 months, and down the road it might be permanent.
Yeah.
All right, we'll grab one more question if you guys have one.
There is also a question about the phytoplankton, and the question was, do they only live next to the coast, or are they found everywhere in the ocean?
Can you please repeat the question?
Sure. The question was, do phytoplankton only live next to the coast, or are they found everywhere in the ocean?
The phytoplankton are found absolutely everywhere, in the surface of the ocean. So they need light, like any other plants. They need light to grow. So anywhere across the global ocean, in the surface layers that are sunlit, you find phytoplankton. But we tend to find more phytoplankton in the coastal areas. The coastal areas are very productive because a lot of the essential nutrients that they need, the phytoplankton need to grow, are found in these coastal waters. One of the most important nutrients or elements that they need is iron. And so although you can have lots of nutrients offshore, you might not have much iron in the water. This iron is leaching out of the rocks in the coastal areas. So there's always a lot of iron in the coastal areas. So it's never limiting. But offshore it can be limiting. And so you usually see this gradient of production of lower production offshore and higher production inshore. And this coast that we're on now in British Columbia is one of the most productive coasts on the planet.
You can think of the open ocean kind of like a desert. There's not a lot of life there, but there definitely is still life there.
All right, that's an excellent point. I want to give a couple more shout outs. We have joining us a grade 10 science classroom in Chatham, Ontario, and they're studying climate change. So Mrs. Brosseau's class, feel free to send us in some questions, and thanks for joining us today. And in fact, we have a question online from Mr. McPhee's group in British Columbia, and they're wondering, how long have you guys been doing your research, and have you seen any areas with very healthy plankton levels?
With very healthy plankton levels, is that right?
Yeah, there was 2 parts. How long have you guys been doing your research, and have you seen any areas with really healthy levels?
Okay. So for this expedition, we've been doing the research for the whole duration, and then in time in British Columbia, for example, we have data sets that go back to the 1950s, well, we've seen a lot of changes over that time, and right now I would say we're in a lower productivity phase, but certainly the productivity in the coast of British Columbia is amazing. I mean, there's a lot of life here. It's as I was saying with the previous question, it's very nutrient rich, so it's definitely a productivity hotspot. And if you go around the coast of Canada, you'll generally find high productivity in all of the coastal areas. The places that are very unproductive are when you go offshore, as Jade was referring to these areas as deserts. You see this particularly in the Arctic. If you go away from the coast in the Arctic into Canada Basin, the productivity is very, very low, because the nutrients in the surface ocean where the light is that the plants need to grow, those nutrients are very, very low. So there's not a lot of productivity there. But certainly in BC, it's an amazingly productive place. We've been putting our nets over the side. I can probably grab you a jar just to show you the plankton, but it's just a green soup right now, and it's quite amazing that we still have these soupy conditions in October. It's fall, but there's still a huge amount of life in the water. And this is going to start to decline now as we go into winter time. Again, it comes down to the light. We have less light in winter, and there's less plant growth. And so, yeah, the productivity will start to decrease.
All right, let's jump to Kingston. Oh, sorry, Jade, go ahead.
Do I have a minute to show the students something that I brought with me that I wanted to share?
Of course, yeah.
Okay, so Brian was talking about how there's phytoplankton close to shore and far out in the middle of the ocean. And in order to study that, we actually have to go out into the middle of the ocean. So that means I spend a lot of time on ships, not just on this ship. And one of the things that we oceanographers do to entertain ourselves when we're out in the middle of the ocean is we see what happens when we send things to the bottom of the ocean. So we're already sending our sampling gear down there. So sometimes we'll add on a couple of extra things, send it all the way down to the bottom of the ocean, and then bring it up and see what happens. So I don't know if you guys have ever swam to the bottom of a swimming pool and felt your ears pop. That's the pressure of the water pushing on your eardrums. So when you send something down 4 kilometers, which is what I did, everything gets crushed by that pressure. So this is a hard hat. I had hoped to find a bike helmet, but they're about the same size. So I wanted the size comparison. Can you hold that for me? So I took a bike helmet and sent it down. I drew all over it, and then I sent it down to the bottom of the ocean. So you guys can see the size difference there. The pressure crushed all the air out of the styrofoam. I've got a couple of other things I'll show you. I've got a cup and a styrofoam head. So the cup started out this size, and this is how big it is now.
Take it close to the...
Can you guys see that? The styrofoam head started out the size of my head, and now it is tiny. I drew all over this one too. So that's one of the things that we oceanographers do to entertain ourselves when we're out in the middle of the ocean.
Very cool. Thanks for bringing those to share with us. That's awesome.
My pleasure.
Okay, so in the interim, I just grabbed some plankton samples. I'm not sure how well you're going to be able to see these, but I wanted to show you how green they are. And maybe...
they're so green that Brian is shining a light on the back side of it, and you can't even see the light shining through.
So all that green stuff is the phytoplankton, and there's a lot of zooplankton in here too, but just you can see how much stuff there is in that water.
So Brian, is that condensed, or is that just from kind of like one scoop?
Oh no, that's condensed. So that's where we put a net down to around 100 meters depth, and yeah, we've condensed all of that water into a jar. So it is dispersed in the water. It's not evenly dispersed. Mostly, like the phytoplankton tends to be in the top 30 meters, but the zooplankton are moving up and down. They migrate between day and night, and during the day, they usually go deeper in the water column because things like birds and herring are trying to eat them, and they can escape in the darkness in the deeper water. And at night, they come up and they feed on all that phytoplankton.
All right. And we're going to jump now to our class in Kingston with Mr. Candela, grade 7s. And you guys have the floor to ask some questions.
So get closer so you can see your face. The camera's there, yeah. There.
So our first question is, has what you've seen so far on your journey been what you've expected?
That's a good question.
Well, it's kind of tricky because we haven't been able to analyze all of our samples. And we've divided up the responsibilities amongst the different legs. So there hasn't been one scientist who's been on the whole expedition. But I think that's certainly what we're seeing here on this BC coast is what we expected. And from what we know from talking to the scientists about the previous legs, things look the way we expect them to look. But we're really going to find out when we start analyzing our samples, and particularly looking at what species are there, and which species we find around the coast. And I think it's going to be really interesting, and I think it's going to be a nice baseline for monitoring changing species distributions in the future.
Well, and earlier, Brian, you mentioned that we weren't expecting quite as much nice weather as we've had. It's been sunny and warm, and that means that the phytoplankton have lots of light available to them. So they've been growing quite a lot, and especially for October, it's not wrong or bad, it's just a little bit unexpected that there's so much phytoplankton in October.
Yeah.
And our second question is, how do you think plankton species will be affected in the future because of climate change?
One of my friends who studies zooplankton, when she's feeling silly, she classifies zooplankton as only two things: crunchies and squishies. So crunchies are the things that are related to crabs, arthropods that have a hard exoskeleton, and squishies are things like jellies. And so one of the predictions that scientists have is that as climate change progresses, we're going to have fewer crunchies and more squishies.
Yeah, that's one way to put it. So I'm just going to, as a zooplankton person, I need to qualify some things that Jade has just said. The first is that the most important, probably the most important crunchy zooplankton are copepods, okay, not crabs. Copepods are one of the most important groups in the ocean, and then there's another group we call krill. Just generally, there's lots of different species, lots of species of copepod, but we'll just call them copepods and krill. These are the crunchies that Jade was talking about. And if you heard earlier, I was talking about the fat content of the animals, and one of the advantages of these crunchy animals, especially from the northern climates, the colder waters, is that they have this high lipid content. So one of the things, so what we expect to see with a changing climate, so this is talk about the warming part of that changing climate, is a shift to smaller animals in warmer conditions, and probably more gelatinous animals. And so we might end up with a less efficient, a less energy efficient food web, and we'll have less productivity being transferred to the higher trophic levels, moving up the food web into the fish. So just like a summary is just we might expect to see decreased productivity. Now, temperature isn't the only factor related to increasing carbon dioxide concentrations, which is driving the warming, right? The carbon dioxide dissolves in the ocean, it forms carbonic acid, and this is something that we call ocean acidification. And this affects animals that have, it can affect them physiologically, just in their biological processes, but it particularly directly impacts the shells of any carbonate forming animal, like a snail, right? So there's a kind of snails, some pelagic snails we call pteropods. Common name for them is sea angels or sea butterflies. What other animals can we think of? Oysters, mussels, these types of animals. So with more carbon dioxide dissolving into the ocean, you have ocean acidification happening, and this can impact the shell development of these animals and affect their survival. So this is one of the processes that we're expecting to see, and actually are seeing here in the Northeast Pacific.
All right, and I just see Mr. Candela at the camera. I'm going to turn his mic on.
Thank you. I was trying to be not so subtle, I guess. The class is going to lunch, but we want to thank you so much for this opportunity. A lot of what you said, I'm going to have to play again because it fits into so many of the units we do in grade 7. More than 50% of what we're going to cover. We're going to revisit your presentations, but thank you very much. Best of luck, and everybody's just going to say goodbye on their way out.
right, Kingston. Well, thanks for joining us today. And I'm glad to hear that you're going to be able to use this for your units coming up. That's what it's all about. We have more questions from online coming in. So let me get to one of them. Here's an interesting one. They're asking, in the dead zones, wouldn't oxygen from the areas around just diffuse back into those dead zones?
You want to take this one?
Yes, this can happen, but I mean the way that dead zones work and form is through this settling of organic matter down into the ocean, down into the depths, and then it's the respiration processes of bacteria and other animals that it consumes all the oxygen. So as long as you get organic matter being shunted down and you don't have too much water movement to replace that water that's low in oxygen, as long as you don't have that water movement, you're going to keep taking oxygen out of the system through all this respiration. And this is part of the reason why the dead zones, the low oxygen areas, can be seasonal, because we have high productivity during the summer times, all those phytoplankton, and then when they die, those that aren't consumed, they sink down to the ocean floor along with animal waste, the waste from the zooplankton. And it's this seasonal production, the summertime production of waste and dead phytoplankton that really stimulates the oxygen take-up by respiration. So that causes a seasonal process. And when that stops, when you stop feeding the system with organic matter, decrease the respiration, the oxygen can regenerate through movement of water, bringing in higher oxygen waters.
All right, great question. And then our grade 10 science class in Chatham, Ontario are wondering, do you think researchers are finding similar things in other locations, and is there a network of marine scientists sharing their climate research?
Absolutely, yeah. It is difficult and it's challenging and expensive to get out into the middle of the ocean in order to do research, especially in the open ocean, but really anywhere. And the only way that we're able to do that is by collaborating. On this ship alone, there were, 15 total projects throughout the entire C3 voyage. As put a call out to scientists saying we're going in all these places. What samples should we absolutely collect? And everyone that was able contributed a project, and all the scientists that have participated have been contributing to those projects by keeping them going, collecting samples every day. So I'm really looking forward to seeing the information that comes out of this voyage after everyone has had a chance to get their samples back to their own labs and have a look at them. Sometimes in science can be a little slow. It's not going to be next week. It's not going to be next month. Hopefully it'll be before next year. But yeah, everyone's working together and sharing all the information they've got. It's the best way to figure out what's happening in the ocean, because it's just such a complex system, just like most environments.
And that's such a great point you make, is the science legacy. Oh.
So, carry on. I'll make a comment when you're done there, Joe.
Oh, okay, sorry, Brian. I was just going to say, you're making such a great point about the science legacy of C3. Long after the voyage has completed, it's going to just carry on for years to come. Yeah, that's right. It's going to. I think that it's going to be a nice benchmark of conditions around, a snapshot of conditions around the entire coast of Canada, and this is something that we can use in the future to really gauge change in our systems related to climate and other impacts. But yeah, I just wanted to say, coming back to these 14 or 15 projects that we have, I hope that you can hear us okay. It sounds like the anchor's going down. There are only four scientists on board at any one time, and so we're working together across lots of different projects, doing lots of different things that we don't normally do, and that's been quite fun.
it's reflecting the community, the science community, and working together. It's probably pretty loud.
Yeah, we can.
Felicity is just close. Oh, much better.
Yeah, we can.
That helps.
So we just
hear it in the background. Yeah,
Yeah,
it wasn't too bad. Okay, I'll hit you guys with one more question from online, and it is wondering what Canada's oceans might look like in the future if changes aren't made and things continue warming, like the waters around.
Canada's oceans are incredibly diverse. So that's a difficult question because what they're gonna look like will differ from one place to the next. You know, if you think about the Arctic, the Arctic system is ice is so important there, and this intense seasonal cycle, the polar cycle. You know, where we can have midnight sun in the summertime, and it's dark. You know, complete darkness in the wintertime. Into down here in British Columbia or on the East Coast in the south. Yeah, we might expect in the future in the Arctic, and we are seeing this, you know, this reduced role of ice, more open water. This affects the nutrient cycling, productivity. Many important processes are determined by the ice. And then also with a warming environment, we might expect to see animals from the south, particularly from the Pacific, because most of the flow into the Arctic is coming through and the Canadian side is from the Pacific. We might expect to see animals coming from the Pacific into the Arctic Ocean. And similarly here in British Columbia, we might expect to see, and we do see this, animals moving, warm water animals down from California, coming up in the Californian current into British Columbia. So these are the types of changes that we're expecting to continue to see happening in the future.
And to simplify it a bit. Oh, go ahead. Sorry, Jade.
It's always interesting to talk about and think about because unfortunately we don't know. Scientists study as much as we can. But the environment is just so many complex systems linked all together. As much as we'd like to be able to know what's going to happen and be able to warn people or tell people or prepare people, right now it's all educated guesses. And I think that's really hard to communicate sometimes that, you know, as much as this is an educated guess, it is still a guess. No one knows yet. But you know what Brian was saying, things are going to be shifting wholeward. So in the Northern Hemisphere, that means things are shifting. So things that used to be in California, maybe now they'll be in British Columbia. Things that were in British Columbia, maybe there'll be a convenient environment for them in Alaska. Thinking about that process, you realize that the things that used to be in the Arctic, there's nowhere for them to go. That's one of the big things that people are concerned about right now.
And I think that
I'll just going to add here that there's you know, we do understand systems quite well, but there's so much research going into exactly that very question. That's a huge question that you just asked there. And it's right at the forefront of what we're trying to do is understand how our systems are going to respond so that we can be better prepared for that. And we have a lot of understanding about this. It's not just educated guesses in some respects, but you know, in some cases the climate's moving into a place where it hasn't been before in human history, and so making predictions, we're developing models to predict what this is going to look like, but it's unfolding, you know, before our eyes now. So we're generating knowledge as it's changing.
Yeah, and I think this very nicely segues into our final question from our group in Chatham, the grade 10 class. They were wondering about how you can affect policy change with people who may not believe in what's happening. And I think exactly what you're doing right now, collecting the data and the research, then making it available is how you'd address some of those concerns and maybe people who are skeptical.
Yeah, so I mean, we realize that from my point of view, I think from most scientists' point of view, it's not a matter of belief. The facts are there. We know climate change is happening, and the questions are how our ecosystems are going to respond to this. This is extremely challenging because ecosystems are incredibly complicated. There's so many different connections between all the animals that are living in these systems, and they're impacted by so many different forces. You know, we talked about temperature, we've talked about oxygen, we've talked about ocean acidification. We haven't talked about human impacts of pollution and fisheries and these types of impacts, which are increasing because of the increasing human population. And so we're really trying to work in an incredibly dynamic environment to figure out how best to manage our systems in this future, in a changing future. You know, this environment is constantly changing. And this is extremely challenging. But yeah, to come back to dealing with or convincing the skeptics, it's about being incredibly rigorous in what we do and presenting the best possible data that's irrefutable. So that you know, people know that there is no question around this issue of climate change.
And I think also what we're doing right now, just talking to people and answering their questions, is really important. It's one thing to publish a paper, which is very important and a lot of work, but it's also very important as well to have conversations about the environment, about our research, and answer people's questions, because it affects all of us.
Yeah, excellent points, and it makes me think of one of my favorite quotes from Neil deGrasse Tyson, which is, "Science is true whether you choose to believe it or not." Science is, yeah, the facts are the facts. All right. Well, Brian and Jade, thank you so much for taking some time to hang out with classrooms this morning. It was great to have classrooms from BC and Ontario, and I'm sure there'll be more who will watch the Hangout afterwards, because they all do pop up on YouTube and are viewable at any time. So again, thanks so much for hanging out, and enjoy the rest of your time on the C3. I imagine you're gonna come home with new friendships, new stories, and lots of new science, which is important too.
Thanks so much for having us. It's been a pleasure to chat with you. And yeah, absolutely, being on C3 is a privilege. It's an incredible group of people we're on the ship with, and we're, you know, have this contact with the communities living on the coast. It's just it's a fantastic experience.
And thank you to everyone who asked us questions. We're happy to talk about what we do.
All right, and Jade as well, I look forward to seeing what you send to the bottom of the ocean next.
Okay.
All right, well, we're going to sign off for today. Once again, thanks so much, everybody.
Right.